Hello class, today I wanted to take a look at some of our problems on our Pythagorean practice number 2. In this video I just want to look at and explain how to set up the questions or draw them out, as the actual solving of the triangles should be pretty straightforward at this point. If you need more time to take a look at the solving steps themselves, feel free to pause the video or look at the posted PDF solution. So with these problems, we of course know that we need to find a right triangle or a series of right triangles in the situation. And of course, we have a few different things that can imply that we have a right angle. The other thing that we know is that if we have more than one right triangle, usually it's very helpful to find the length of the shared side that is going to link the two triangles together. And that way, if we have enough information to solve one triangle, we can solve for enough information to solve the second one. So let's take a look at question 1. We've got a 65 centimeter tall air conditioner requires a support platform or shelf. So we know that we have some sort of shelf here or platform, which is going to be holding up a 65 centimeter tall air conditioner. So here's my AC, and I know that it is 65 centimeters tall. Now this is hanging off of a wall. So we have a chain between the wall at the top of the air conditioner and the front edge of the platform. So let's go ahead and set up our wall here as well. And I'm going to assume that this platform or shelf is not leaning or tilted. So since my vertical wall is vertical and my platform is straight horizontal, I know that there's a right angle between the two. And I'm told that there is a chain that is 80 centimeters long between the wall at the top of the AC and the front of the platform. So here's my chain, and I know that is 80 centimeters. And then likewise, since the chain is on the wall at the top of the AC, this is going to be my 65 centimeters between the bottom of the platform and the top of the AC. Now Sam wants to add a brace underneath the platform, so over here somewhere. And our brace needs to be 20 centimeters below the platform on the wall. So if we go along our wall 20 centimeters, then that is where our brace is going to go to. And we want to know how long that brace is going to be. So that is our drawing of the situation. And you might notice here that we have two right triangles. We have the top right triangle, which I'm going to outline in yellow. And that top right triangle has enough information to solve. It has two side lengths. We could solve for the unknown length of our platform. Okay, the bottom triangle, which I'm going to outline in green, does not have enough information to solve at this time. It only has one known side length over here. And so that is not enough information to solve for a side length. However, we do have a shared side, which is our platform. And so we can solve the top triangle for the width of the platform, use that width in the bottom triangle to solve for the length of that brace. And so here's quickly what that might look like. Solving the top triangle, we would have our 80 centimeters as side C in our Pythag. We'd have our 65 centimeters as side B, and our platform would be our unknown side A. Solving that out gives us our platform width is the square root of 2,175. As a decimal, that's approximately 46.6 centimeters, but we're actually going to keep it as the square root of 2,175 to keep it exact. We can then put that value into our bottom triangle here, and then use those sides to solve out that our brace is about 50.7 centimeters long. Again, if you need more time looking at that solution, you can pause the video or you can look at the posted solution on Google Classroom. So we take a look at question 2. It says a teacher sets up a relay from one corner of a square gym to the opposite corner. So let's go ahead and draw it. Here we have our square gym. And since it is a square, we do know that we have right angles in all the corners. And we're told that with our square gym, we set up a relay that is from one corner to the opposite corner. So here's our relay, going from one corner to the opposite corner. And that distance of that relay is 42 meters, not centimeters. That would be a very small gym. And so we're asked what the side length of the gym is and what is the area of the gym. So we do have a right triangle here, and I'll outline it in yellow. So here's our right triangle, and we are looking for the side length of the gym. So we know in a square the side is the same on the width and the length, and we're looking for that side length. So in terms of solving out this triangle, we do have a known side. Now it might appear that we don't have enough information to solve here, since we would need to know two sides. The key to this is that the two unknown sides are actually the same. So instead of using different variables for them, we can use the same variable. So in our a squared plus b squared equals c squared for Pythag, we do know that side c is going to be our relay, and so we know that that is our 42 meters. Of course, we'll have to square that in our equation. But both a and b are length s. Now, of course, we don't know what length s is, but we can substitute it into both spots of the equation. And so if you notice, we only have one unknown variable here, variable s, which means we can solve for it. In terms of solving for this, let's write those without brackets first off. And then if I have one of something and I add another of that same thing, then I have two of that thing. So 1s squared plus another s squared gives me 2s squareds, and that'll equal my 42 squared. And that's the key to being able to solve for that side length in this question. Finishing off that approach, we would divide both sides by 2 to undo our multiplication, remembering that when solving, we're working in reverse bedmass order. That'll give us s squared is equal to 882. Square rooting both sides would give us the side length of the gym, which in this case is approximately 29.7 meters. However, for the area is just s squared, and we had already calculated that s squared is exactly 882, so we don't need to re-square our rounded 29.7. We can just use the fact that s squared is 882. Since the area is s squared, then the area must also be 882. In question 3, we're told that the formula for the area of a triangle is area equals base times height divided by 2, and we want to know the area of an equilateral triangle with a side length of 4. So first thing I'm going to remember from elementary school is that an equilateral triangle has all the same sides, or 3 equal sides. And the other thing I know, because I know I'm going to be looking for right triangles, and equilateral is not necessarily right, is that our h here is going to be perpendicular to the base. So let's go ahead and start with a equilateral triangle. Again, this is just a sketch, of course, and we know each side is 4 centimeters long. So all 3 sides are 4 centimeters long. The area of the triangle will be the base, which we'll arbitrarily call this side here, or our base in our triangle, let's even say, just to avoid confusion, times our height. And remember, our height is always from the base, perpendicular up to the opposite tip, and again, with that right angle there. So it does appear that I have a right angle triangle. I've got this one over here in yellow, and I've also got one on the other side. Of course, 2 right angles make a straight line, so we know there's a right angle on the other side as well. Now, as it turns out, these 2 triangles are the same. They share this middle side here, so that must be the same. They share a 90-degree angle. The other angle has to be the same as each other, because all the angles in an equilateral triangle are equal. And then that means that these 2 angles up here are the same as well. So we have all the angles in your triangles the same and 2 same side lengths. Means that these triangles are in fact identical to each other. Since they're identical to each other, I know that this length must be the same as this length. Since they add together to a total of 4, I know that each of these is 2 centimeters. And that gives me enough in one of these triangles to be able to solve for the unknown height. I do know that this bottom side here is 2, this hypotenuse is 4, we have a right angle. There is enough information to solve this triangle for the height. So this is what it would look like to solve for the height. We're going to plug in that a and b in our triangle are going to be h and 2 respectively. and then the hypotenuse across from the right angle is 4. So that gives us h squared plus 4 is equal to 16. Subtract 4 from both sides gives you h squared is 12. Square root both sides, and the height of this triangle is the square root of 12, which is approximately 3.4 centimeters. But since we are not answering for the height, we want to answer for the area. We're going to keep that exact as possible for now, so we'll say that the height is square root of 12. Again, substitute that height into our area formula. Area is base times height divided by 2. The base was 4. The height perpendicular to that we just figured out is the square root of 12. We have to divide that by 2. Now, 4 divided by 2 gives me 2. And then 2 times the square root of 12 on my calculator gives me 6.928, which is 6.9 centimeters squared, rounded to the nearest tenth. Okay, question 4. We are told that square dish is symmetrically embedded inside square cake, as shown below. The side length of cake is 8 centimeters. So we do know that all the way along this whole side here is 8 centimeters, and since it's a square, this is also 8 centimeters. Now, similar to that last one, since we are embedded symmetrically inside, then we know that this length, and 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 this length are all the same. And since 2 of those make a length of 8 in total, we know that each of them, must be 4 centimeters, so that they add up to the 8 in total across the whole side. Okay, now we also know that these are squares, so we know that these are right angles inside of here. And that gives us many right angle triangles to choose from in terms of solving for our side length of square DISH. So we can go ahead and look at any of these right angle triangles, but for example, that one, you know these two sides are 4 centimeters each, and you're looking for the unknown side length, let's even call it C, across from the right angle. Okay, you can then use that side length to calculate the area of DISH, and then use that area to answer the question about the percent. So again, if you need more time to take a look at that solution, you can do so by looking at the posted copy on Google Classroom. Okay, it turns out that the original drawing gives us 200%, or cake is 200% of dish, or double as big. If we change that to 3/4 way along, of course, we just change those side lengths for where they intersect, and that gives us a triangle with sides 6 and 2 instead of 4 and 4, and that changes it to only turn out to be 160% of cake's area. Final one here, we're told to mathematically prove whether this triangle is right. On first inspection, it looks like it's possible that there is a right angle over here, but of course we don't know that to be true to mathematically prove it. The issue here is that there's only one side that I know its length for sure. I do know that this length all the way up and down here is straight along the grid line, so I can just count those. 1, 2, 3, 4, 5, 6 grid lines. So this length here is 6 units. My issue is that this length here is not 1, 2, 3 units. It's at an angle. Obviously, we're not going perfectly through our grid lines here. So that is going to be difficult to know just by looking at it. The trick here is to find the right triangles, or right triangles, plural. And to do that, you need to go ahead and cut this triangle into 2 right triangles. So if we add that cut line there, we now know a third side, or a second side, that is absolutely positive its length, which is 3 units from there to there. We can also then say that above this cut is 4, and below is 2. And those are lengths that we know for sure. This again gives us 2 right triangles that we can absolutely solve with known sides. So we've got this top one with sides 3 and 4, and we've got this bottom one with legs 3 and 2. And those are triangles we'll be able to solve to figure out the unknown lengths along the hypotenuse of each of those triangles. Once we have those unknown lengths, we can apply them in our Pythagorean formula to check if the overall triangle ABC is in fact a right angle triangle or not. So I hope that's helped you understand the setup of these questions. Again, if you need some help looking at the actual solution to the question once it's been drawn, please do check the posted copy on Google Classroom. Hope that helps.